Hello everyone, this is Mrs. Lindsay. Today we're going to talk about exponential functions, how exponents work with expressions and equations, and then the shapes and properties of exponential functions and graphs. First, I would like you to go ahead and take a look at properties of exponents with your bases here. These are some property rules. Take a moment, fill in what you can, what you remember from your previous knowledge, and push play to check your answers when you are finished. Okay, so go ahead and check your answers here. Again, these are rules of exponents that hopefully should be a review for you. We have been using the radicals and our negative exponent rules, but again, might need a little refresher on some of the other ones. But let's go ahead and take a look at some of these graphs and some of the features of exponential functions. So starting on the left-hand side, we have the general shape of f of x equals a times b to the x when b is greater than 1, where the difference on the right is where b is going to be less than 1 and greater than 0. So we'll talk about the differences of those. So first of all, on the left-hand side, where it's greater than 1, this is what we call exponential growth. And it'll look something like this. And it has a horizontal asymptote at y equals 0. It has a y-intercept of 0, comma, a. So over to, on the right-hand side, when b is less than 1 and greater than 0, that's what we call exponential decay, so it's decreasing. Still has the same y-intercept of 0, a, still has a horizontal asymptote at y equals 0, okay, but now it's decreasing, where on the left-hand side it's growing, okay. So some characteristics, a couple we've already talked about. On both sides, they have a y-intercept of 0a. Horizontal asymptote, y equals 0. Those are the same. Domain. So hopefully if you take a look at both of these, you realize again domain of the exponential growth is going to be all real numbers, as well as the decay will be all real numbers as well. And if you look at the range, again, kind of thinking minimum and maximum, cannot go below that horizontal asymptote of y equals 0, so it goes to 0 and infinity. And it's exactly the same on the decay side as well. So those are just some general characteristics of some exponential graphs. And we're going to go ahead and take a look at an example here where we have y equals 2 to the x. So this is the graph of y equals 2 to the x. So as we can see here, we have 0, 1. That is our, I'm going to add that over here. That is our y-intercept. And we have a horizontal asymptote as y equals 0. And again, domain and range. Domain is going to be all real numbers. Range is going to be 0 to infinity. Okay, so let's work with graphing some of these functions where we have transformations. So if you notice from the original graph, it's changed slightly. We now have where it says y equals 2 raised to the quantity x plus 2. So if we compare that to our original function, which I have graphed over here to the left, which is y equal 2 raised to the x. If you recall from our transformations, this 2 plus 2 is attached to the x. So it's, it has the opposite effect on the graph. It's going to be going left 2. So I can take all my key points from my original graph, which we know the y-intercept of 0, 1. Then I also have order pairs 2, 4, and 3, 8. And I literally can take those on the graph over here on the right to graph 2 raised to the quantity x plus 2 and count to the left 2. So 2, 4 over to the left 2. And then up 3, 8 to the left 2. So of all these characteristics over here, and if I still draw this in, my horizontal asymptote did not shift at all from y equals 0 because, I can go ahead and note that down here, because I just shifted to the left too. I did not change it up or down, so that will not also change anything with my domain or range. So domain is still 0 to infinity, and the range is 0 to infinity, and the domain is negative to infinity. It did, however, change my y-intercept. And we can visually tell here that our y-intercept is at the order pair 0, 4. Okay? Please note whenever you're graphing any of these, you must include the asymptote to get full credits for graphing any of these. Okay? You got to put that dotted line in there to represent your asymptote. All right, so let's try another one. Again, comparing here to our original graph of y equals 2 raised to the x, which again we would call the parent graph. Now I'm going to, again, I have the quantity x minus 4 as the exponent. So again, that does the opposite effect. It'll go to the right 4. And then I have the minus 5 here, which is not attached to the x, so has the normal effect on your y. So it'll go down 5. So again, if I take those key points from our original graph here, y-intercept is 0, 1, 2, 4, and 3, 8. I literally can count to the right 4 and then down 5. So I have 2, 4, so I can go right 4 and then down 5. And then the last one is 3, 8. So I'll go right 4, down 5. And then it does have an effect on my asymptote. My asymptote was originally at y equals 0. Well, I shifted down 5. So now my y equals 0 asymptote will now be at y equals negative 5 because I had to shift down 5. And then I can go ahead and complete my graph. That also then had an effect on my range because again it shifted it, our minimum is going to be lower, shifted it down 5. So the range will now be negative 5 to infinity. However, domain is still going to be all real numbers. Let's think about our y-intercept. This one's going to be slightly different because our 0, 1 shifted. And so we have a value here where we're not sure what we can do. So if you recall, x is 0. How can we find that in our original problem? Well, we literally can substitute that into our problem. So we have 2 raised to the 0 minus 4. Subtract the 5. So then we'd have 2 to the negative 4 minus 5. Well, 2 to the negative 4th, if you recall, that's going to actually bring the 2 to the denominator and make that exponent positive. So I'd have 1 over 2 to the 4th minus 5, which that's 1 over 16 minus 5. And if I plug that in my calculator, it's going to be a decimal or a fraction. I'll go ahead and leave that in fractional form. We get that to be negative 79 over 16. So that is going to be our y-intercept. All right, I would like you to go ahead and try this problem, but I'll give you a little hint here. So if I have the 3 outside there, so that's going to have an effect just like the negative 5 in our other problem was not attached to the x, it was outside of that, so it affected the y's. So we subtracted all of our y's by 5. So in this case, I'm going to multiply all of my x's by, all of my y's by 3. So I don't change my x's. So I'm going to take every single y value from all these points that we've been using before, 0, 1, and 2, 4, and 3, 8, and multiply your y's by 3. Okay? Go ahead and fill all these in as well as your y-intercept. Pause, see how you do, and then we'll come back and discuss it. Okay, so I took all my y values and I multiplied by 3. So here my y value is 1, so you can see that moved up to 3. Here my y value is 4, the original value, but I had to take 4 and multiply by 3. So that, went up to 12. So as you can see, it's really stretching this graph. So what we say in terms of transformation, we say it took the graph, it stretched it vertically by 3, because it took all my y values and I tripled them essentially. Okay. All right, so if you realize all the examples that we have done currently have been where b is greater than 1, and those are all exponential growth models. So let's take a look at an exponential decay model. So here's where b is in between 0 and 1. Okay, so if this is y equals 2 raised to the x, our parent graph, and now 2 is in the denominator, so in other words, another way of writing this is 2 raised to the negative x. How does this change all of our values? Well, what we can do, if we're unsure, is let's make an xy table. We'll put a couple of negative values in there, a couple positive values. If I have 1/2 raised to the negative 2, that's really going to be 2 squared, because the negative 2 will bring the 2 up to the top, so I'll get that to be negative 2, 4. And I can go ahead and graph that. So same thing with 1/2 raised to the negative 1, that's really going to be 2 to the first power, so again that's just 2. Anything raised to the 0 power, hopefully you remember that from the very first rules of your properties that you filled in there of exponents, that's going to be just simply 1. And now I'm going to have 1/2 raised to the first, so that's literally just 1/2. 1/2 squared, so that's going to be 1/4, because I take 1 and square it, I take 2 and square it. So then I can go ahead and graph 1 1/2, and then 2 1/4, and as you can see, that's getting closer and closer to our horizontal asymptote there of y equals 0. And again, the range is still 0 to infinity. Domain is negative infinity to positive infinity. And then we have our, also squeeze this in here, our y-intercept is at 0, 1. Okay, so this concludes our refresher on graphing exponential functions, as well as some of our properties of exponents.